So for rule 2 is when you have ring deactivating substituents, they are meta-directing. This is very important. So remember, electron donating groups, ring activating substituents are ortho-pair directing. Deactivating substituents, electron withdrawing groups, are meta-directing. This is an important, probably the most important distinction you need to know in this chapter. And the reason why is because the meta position is the least destabilized. So we will see that in the following resonance structure. So be patient. These resonance structures take time to show. So we're just going to use an electrophile here. We don't have to draw a group. It just, again, all you have to do is just change a group here. Electrophile is the generic one. So let's start with the ortho. So if you add the ortho group, you add the group to the ortho position, which is right there, you will get the following resonance structures. Here's E, there's H, there's a positive right there. Once again, you should know the resonance structure right there. There's a positive right there. And then this is the next one. And then you have a positive there. This one looks a little bit weird, but let me just fix it up a little bit here. Okay, here's a problem. What is the problem? Can you see it? There are two positive charges adjacent on adjacent carbons. So you have this one, two positive charges adjacent on adjacent carbons. This is very unstable. You know, positive charges repel each other. So that's going to just simply destabilize the molecule. So that's why this is very bad. Okay, I don't know what happened here, but the numbers did not. So that's basically what happened, is you have two positive charges. Now let's go on to the next one. If we do a meta, here's E. Oh, added it in the wrong place. Sorry about that. Remember, we need the meta positions, not the ortho. So that's positive right there. And here's E and the H. Here we go. So our next, sorry about that, would be moving that way. So here's the positive. And then, of course, one more resonance structure. E, and H right there. So while this one doesn't have an octet, it's still better than having two adjacent positive charges. There's a positive on the N, and there's a positive on this carbon, on the nitrogen. So this one we can say not this one right here. As unstable so it has a lower energy carbocation.